Yeah. Morning all. Yeah, before I start, can anyone please confirm whether my voice is clear, whether the screen is visible or not? Yes.
Yeah,
Okay.
yes.
It's okay.
Fine, fine. So I was just waiting for the students to join the meeting. Sorry for the delay. So myself, I'm Vijay. Like I hold 20 plus years of experience in different technologies, right? So as part of today, I'll be just discussing what is PySpark. What is a Spark first? What is a Spark? And why PySpark? Need for PySpark. PySpark features. Yeah. PySpark features as compared with other languages, right? And use case. PySpark use case. Real-time use cases. Job market of PySpark. This is what I'll be discussing in today's session, right? What is, sorry, there's a typo mistake. What is a Spark? What is a Spark? Why PySpark? Need for PySpark. PySpark features. PySpark real-time use cases. Job market of PySpark. So yes, starting with this, what is a Spark? I define Spark. Spark is a, okay. It is an open source distributed cluster computing, check it, distributed cluster computing framework. Yes. With parallel processor style, with a parallel processor style, right? With in-memory computing feature, with in-memory computing feature, right? Yes. Used for large-scale data processing. Large-scale data processing. It is an open source distributed computing framework with the parallel processor style with in-memory computing feature used for large-scale data processing. Okay. Spark is one of its Spark is a processing model. I can say it's a processing execution engine. It with a very high rate of speed. It is going to process huge data at a very quick rate of time. Yes, it is an open source. So okay, can we also discuss as part of this course? 1 second. Some queries are given, right? Yes. Chella CP, right? It's not at 9. It's 8 o'clock only. Yes. I will discuss the course content at the end of this, right? At the end of the session, I'll be just briefing you about what I'm going to discuss, right? Yes. Yeah. Distributed framework, right? Here, Spark data is getting distributed across multiple systems. It's distributed across multiple systems, right? And it's going to be executed by multiple systems parallelly with in-memory computation features. That too, Spark data is distributed across multiple RAMs of multiple machines and is processed parallelly, right? Yes. And if we talk why PySpark, see, Spark can be coded with multiple languages. Spark can be coded, yes, with multiple language, multi-language support. Using Python, using Scala, using Scala, using Java, and using our language. So Spark can be coded with multiple languages, right? Multi-language support, we say, using Python, Scala, Java, and online. Frankly speaking, by default, Spark built using the Scala language. Default. By default, Spark comes with Scala. Scala is the native language of Spark. Previously, yes, if we talk in the initial days, right, of Spark when it was introduced, I'll just come back to the history of Spark. But when Spark was introduced, Scala language is mostly preferred. But today, right, today in the industry, right, Python is mostly preferred, where it is providing many modules towards, especially for analytics, right? So Spark with the Python implementation, Spark with Python implementation, right? These two are mostly used in the market today, right, to the industry. Previously, Scala was used, now Python is used a lot. These are never used, means we can also implement Spark using Java and our language, but they are not preferred a lot. These two are the preferred languages for implementing Spark. That's why if you see the environment Spark execution, right, when you are executing in any environment, it provides all this language support. You can select any language. When you are executing the Spark coding, you can select the language which you want. The Spark functionalities remains the same in all these languages, but programming is going to differ. How you define a variable, how you define a function, how you define a collections, right? In this Python, in Scala, in Java, that is going to be different, right? Yes. Okay. So Spark is an execution. Once again, I say it is a execution model. It's a processing model with parallel process style. Data is distributed across multiple systems, processed by multiple systems with in-memory computing feature used for large-scale data processing. And here, as part of our course, I'll be discussing Spark with Python implementation. So here you may ask, why PySpark? Why PySpark? Yes. Why PySpark? I can say PySpark is the Python API to use Spark. PySpark is the Python API to use Spark. Spark is an open source cluster computing system which is used for big data solution. I can say PySpark is the lightning fast technology that is designed for fast computation. This PySpark is one of the demanding tool for data engineers to work with the bigger data sets. See, I can say PySpark is used today, right? Is used for uh, running distributed SQL, for running distributed SQL, I'll just say creating data pipelines, creating data pipelines. It can be used for ingesting data into database, ingesting data into database, running ML algorithms, working with graph algorithms, working with graph algorithms, working with streaming. Yes. Streaming, working with streaming or streaming data. What do you mean by streaming data? Means data which keeps on generating, data which keeps on incrementing, right? And the graph algorithms, right? And for ML algorithms, ingesting data into database, creating data pipelines, running distributed SQL, right? Yes. So why you may ask, what is the need for PySpark today? Need for PySpark. See, today if you see huge data is getting generated, not in KBs, MBs or GBs or TBs, data in petabytes. data in petabytes. 1 petabyte equal to 1024 TB. 1020 already 1 TB is the last storage unit. Today, if we see, lot of applications are generating data in petabytes. 1024 of TBs, right? 1 petabyte, right? Today, if we talk about applications like Facebook, Twitter, YouTube, means if we talk about the YouTube videos uploading, if you take the Google querying, or if you take uh, e-commerce websites like Flipkart, Amazon, they are making huge data, huge transactions. They generate bank transactions, telecom transactions. Everywhere we see like huge data is getting generated, and for processing that huge data in quick time, this Spark. Spice means if data is generated. If you see large amount of data is getting generated through offline or through online, this data contains hidden patterns, unknown corrections, market trends, customer preferences, and other useful informations. We need to extract some valuable information from the raw data. For example, if you're given a huge data, I just want to check the user preferences. For example, uh, a data is given, some URLs are given, that users have clicked that many URLs. From that URLs, you need to just what you can say, track the user preferences. Users are interested in which course. Most of the clicks are for which course. So those kind of crossing I want to do are for hidden patterns, market trends, customer preferences, other useful informations, right? Everything I can extract it from the raw data. So we require some efficient tool for performing different types of operations, the two on the big data, huge data, right? I want to perform different types of operations on this huge data. So already we think we have got different tools available in the market. We have got many tools to perform tasks on this, but they are not that much quick or fast for processing. So we need some scalable and flexible tool to crack this big data, huge data, and gaining some kind of benefit from this. So PySpark. So PySpark is such a kind, right? PySpark is such a kind. So combining Python along with this Spark will be the very efficient for the world of big data. That's why Apache Spark community, it came up with a tool called PySpark. PySpark, right? Python API to use a Spark. So we see many built-in functionalities. No need to write huge codings here. We have got many built-in functionalities, many libraries given by Spark, like Spark, like Spark MLA, Spark Graphics, Spark SQL, Spark Core, right? In this way, many are things using which you can easily perform the processing, right? Yes. See, if you see main PySpark features, if we talk, what are the main features? Means first thing is in-memory computation. In-memory computation, right? In-memory computation. In-memory computation means your data is going to be distributed across multiple RAM memory, right? So yes, it is distributed across multiple RAMs of multiple systems and are processed parallelly. Why very high speed you are going to see in Spark means your data is going to be huge. Your data object is a very big data object, means like in TBs or P petabytes of data. Means what happens? You are going to divide that into multiple partitions. That partitions are going to get distributed across multiple RAMs of multiple systems. So later I'll discuss about these things, right? Cluster, we have got a cluster where multiple systems are involved, where multiple systems are going to store the data, multiple systems are going to process the data parallelly. That's why we see very high speed here. And that too, your data is storing within the RAM level, memory level storage and memory level processing. Yes, I'll just brief you about all those things, right? Yes, Vishal Kumar, I'll discuss about those things. Yeah. Means your data is distributed across multiple systems, stored across multiple systems, and multiple systems running parallelly, right? And giving the result. Whenever you make any query also, whenever you make any query, your data is going to be retrieved from multiple systems. Whenever you make any kind of SQL querying, right? Yes, your data is going to be retrieved from multiple systems. Okay? It's going to be executed on multiple systems and processed by multiple systems, right? That's why we see very high speed. We see very high speed for it, right? Okay. In-memory computation. So if we talk about the speed of Spark, especially this PySpark, right? I'll come back to these features. Already many tests were conducted. Many tests were conducted, right? If we see, Spark is 100 times faster, 100 times faster than normal disk processing. See, already many tests were conducted. Yahoo has conducted a test to check the speed of different databases. It has taken a table. Yahoo has taken a table of 100 TB consisting of 1024 columns. 1024 columns. The task was sorting based on 16 columns. Sorting based on 16 columns, right? What is the time taken? What is the time taken by different databases? Oracle. To handle this, it has taken around 3.5 days. Means 100 TB of data to handle it. So MySQL, it has taken nearly 6 days. It has taken around 6 days. And we have got some specialized databases used for data warehouse purpose, like we heard about Teradata, right? Teradata, it can handle TBs of data. It has just taken 4.5 hours. And another specialized database, right, used for data warehouse purpose, that is Netija. It has just taken 3 hours of time. And finally, if you heard about this big data technology like Hadoop, has just taken 3.4 minutes. If you talk about Hadoop has just taken 3.4 minutes, right, to process it. So now if you talk about this Spark speed, Spark is 100 times. See, already these have taken days of time. These have taken hours of time. These have taken minutes of time. Spark is 100 times faster. Spark is 100 times faster than Hadoop, I'm saying, right? So already it has got very high speed in minutes of time, but Spark 100 times faster than that. See that the processing speed of Spark, right, as compared with other things. Very high speed because of the feature I was talking about, the feature in-memory computation in the Hadoop disk level, right? The everything you see in Hadoop, but only thing is in-memory computation you won't see. In Spark, we see in-memory computation where data storing within the RAM level. Later, I'll brief you about how exactly the data storage and processing is happening here in Spark. In-memory computation, data is storing within the RAM level, memory level, and processed parallelly. Second thing is lazy evolution in Spark. Lazy evolution, we say. Lazy evolution. What do you mean by lazy evolution? Active evolution. Active evolution means whenever defined, whenever declared, immediately executing. See, lazy evolution, right? Lazy evolution and active evolution. Just like normal functions. Okay. Just like if you see in programming language, you see functions, right? Whenever you define, they won't execute until you make a call, until you make a function call, then only they get executed. And similarly here, whenever you define a data flow, whenever you define a data flow, until you make some action, it won't going to get executed. Lazy evolution, whenever you make action, then only it gets executed. Until then, it won't execute. Lazy evolution, we say. See, which is better for this means lazy evolution means whenever required only, I will make an action and I will execute the data flow. When required, what time, so we can execute that entire data flow. And here, one more feature, persistence feature. Persistence feature you are going to see in this PySpark means already executed transformation. Again, we can reuse it. We can make use of it. Again, no need to re-execute. Again, no need to re-execute from the beginning. Already executed transformation output you can reuse, right, in your flow. Persistence feature. In most of the other processing technologies, right, already executed transformations cannot be reused. Again, you need to execute from the beginning. But here, based on the persistence feature provided by this Spark. And one more feature is partitioning. What is the advantage of partitioning means? Your data, huge data, instead of storing in a single system, means it's divided into multiple partitions and distributed and processed by multiple systems parallelly. Okay. And in Spark, we have got powerful fault tolerant model. Powerful fault tolerant model. Powerful fault tolerant model means as these are running on multiple systems, as these are running in multiple systems parallelly, right? The data is distributed. Suddenly, if any system goes down, right? And Spark has got the capability of regaining the lost partition, right? Yes. So mainly in-memory computing feature, persistence feature, lazy evaluated, whenever required only we execute it, divided into partitions, distributed and executed parallelly, right? And powerful fault tolerant model, right? Yes. Some of these examples were exactly this PySpark used in the real-time scenario, right? So if we talk about this financial banking and financial sectors, right, where to retrieve the customer's social media profile and to analyze and gain useful insights and can help in taking right decisions and even in credit risk assessments and fraud detections, right? And also the in entertainment industry also, right? Even Spark is used to today, like especially like popular OTT platform like Netflix using Apache Spark for real-time processing, right? Personalized online movies or web series. It processing around 450 billion events per day as over the server side applications. And also even in the healthcare, right? Even today, like Spark is used to analyze the patient's health condition, right, based on their previous health records, and also which patient is going to face the issue, right? Those things it is going to predict. Even if you talk, Spark is used today in e-commerce trading, right? So especially like e-commerce websites like Flipkart, Amazon, they're using Apache Spark for advertising, right, to enhance the customer experience and increasing the overall performance. And even in tourism industry to provide advice to millions of travelers, right, by comparing millions of websites. Okay. Yes. If you see the evolution of Spark, right? Yes. It was developed in the year, it was introduced in the year 2009. Was introduced in the year 2009. Later, it was open sourced. It was introduced in the year 2009, but it was open source. Spark was open sourced. in the year 2010. And later Spark was donated. Spark was donated, right, to Apache Software Foundation, right? Yes. In the year 2013, And if you see from 2014-15, right, a lot of POCs were done, right? And Spark initially, we used Scala programming, right? Because Scala is the only language which Scala is only used for Spark environment. So Spark is providing multi-language support where you can execute in any of the language, but Spark functionalities remain same on all this. Spark execution generations. If you talk about this execution generations, right? Previously, execution generations, if we talk previously in Hadoop, we got MR, Hadoop MapReduce, we used to say. Spark. Executions previously, like if you go back like 15 years ago, right? We used to have Hadoop MapReduce, later Tej, Spark. Okay, MapReduce, okay, I said it is Spark is 100 times faster than this. And there are many drawbacks with this Hadoop MapReduce I'll be discussing, right, as compared with Spark. If we talk about this Tej and Spark, the difference between this Tej and Spark and what advantage Spark has got means both follows DAG, directed acyclic graph model. What is that? Directed acyclic. Not like a directed acyclic graph model, not like a closed loop. All right. But Sage doesn't follow in-memory computation. Sage doesn't follow in-memory computation. Right? Yes. Spark has got a very high speed. So Spark has got high speed over Sage. So if we talk Hadoop MapReduce, Sage and Spark, if we talk Sage and Spark, both uses DAG model, directed acyclic graph model. I'll be discussing about this DAG. Here Spark follows DAG, directed acyclic graph. But here Tej doesn't follow in memory. So because of that, Spark has high speed over Tej. If we say what are the other in-memory computing systems in the market? Other in-memory computing systems. HANA, if you heard about HANA, right? HANA is also a in-memory computing system. Other in-memory computing system is HANA. We talk about HANA and Spark. Both are in-memory computing systems. Both are in-memory computing. But HANA is not distributed. But Spark is a distributed RAM. Distributed RAM means, for example, you got 10 systems. 10 systems. Each system has got 64 GB RAM. Assume it has got 64 GB of RAM. Total RAM capacity 640. 640 GB RAM. If you take 20 systems, 1280, 1280. If you take 40 systems into 4, means in this way, if you are increasing the systems, distributed RAMs where your data is going to be distributed across multiple RAMs in the case of Spark. That's why distributed RAM we can see. That's why it is going to accommodate unlimited huge data sets, huge data objects are accommodated by Spark. Means multiple systems, a huge data object, a file is divided into smaller partitions. They're going to be distributed across multiple RAMs, right, of multiple slave machines and are executed parallelly, right? Yes. Spark mainly designed for batch applications, iterative algorithms, mainly for batch applications or iterative. What do you mean by batch applications? Batch processing we say. Online processing we say and the batch processing we say. What is the difference between online processing and batch processing? Online processing means you are just, for example, you are making an online transaction. Means compulsory user has to give some input for online. If you want to perform some any online transaction online, compulsory user is required. User performs some kind of operations. He gives input. If you are making a transaction, source account, destination account, user interactive applications. User interactive applications we call online applications. Batch applications are not user interactive applications. User non-interactive applications. User non-interactive applications. It's not for online applications. For means millions and trillions of records. For example, user non-interactive applications means user doesn't give any input. For example, a simple example, generating credit card statements for millions of customers. Here user is nowhere required. Phone bill statements generations for millions and trillions of customers. So yes, in this way where millions of records are involved, right? Batch applications involve like millions of applications. Okay, everything, these things will happen in the background, right? Right. And for iterative algorithms, right? Means Spark is mainly for iterative kinds of algorithms. Most of these ML algorithms or this data analytics related algorithms are iterative in nature. Every time when we apply, we are going to get some error. We keep on applying iteratively until the error becomes 0. And even for interactive SQL queries, and for streaming data which keeps on generating like, yes. Yes, Anji, right? Yes, Anji, yes, I'm going to discuss about the same thing now. Yeah, mainly designed for these things. Okay. So today I was just briefing you about what is a Spark, that features of Spark. Yes, just how the Spark as compared with other things. Later I'll be discussing with many other technologies, right? As Spark processing comparison with other processing technologies or other technologies, I'll be discussing more in the tomorrow session. So, and one more thing, this Spark processing I'm going to show you on. One second. So we are going to see Azure Databricks. I didn't discuss anything about this Azure Databricks. Later in the tomorrow session, I'll be briefing you more on this Azure Databricks. So what is normal Databricks and what is Azure Databricks and how this is related with PySpark and Azure Data. So we will be everything in the cloud environment. The cloud we are going to use is Azure Cloud. In that Azure Databricks, we are going to execute these things. So I'll try to give the knowledge about all these things and also the prerequisites required for understanding this PySpark. So in the tomorrow session, just I'll be briefing you much on this Azure Databricks, right? I didn't discuss anything in today's session. I was briefing you about Spark because Spark is the main execution weapon, right? If in data engineering side, if we talk about data engineering, Spark is mostly used and has got high demand today. And that too Spark with Python implementation, right? It has got a huge demand. Uh, it's one of the demanding tool for data engineer, right? To work with bigger data sets and processing it very quick time, right? Fine. Just check this course content, what I'm going to discuss in brief. So I'll be giving knowledge about this Azure Databricks and this entire PySpark. Just check with this course content, right? Azure Databricks with the PySpark. So first I'll be providing knowledge on this, some knowledge on this big data and this Hadoop, what you need to understand, some knowledge on this, an introduction to Spark and this introduction to cloud computing, introduction to these things, and introduction to this Azure Databricks architecture, and Databricks, creating Azure Databricks, creating a Databricks workspace, Databricks service, because everything today like Spark total execution happening by using this Databricks. So you need to clearly have the knowledge about Databricks, right? Everyone. If you go for PySpark, you need to have knowledge on this. Yes.
What
Once,
prerequisite?
one second. Let me complete this. I'll give time for your queries. Databricks service using Azure Resource Manager, ARM templates, adding users and groups to the workspace, creating a cluster, getting started with notebooks and jobs, and displaying clusters, starting a cluster, terminating a cluster, deleting a cluster, cluster locks, types of cluster, all-purpose clusters, different types of clusters, right? We're discussing in the Databricks pools, with pools, without pools, cluster modes, and we have got a Databricks utilities, data utility, file system, notebook utility, library utility, CQS widgets, and Databricks integration with this different like Azure Data Lake, Azure SQL, these things. And coming to this, the PySpark, right? Mainly the data frames API. So creating a data frame, empty data frame, converting a data frame, right? Structure type, struct field, column, select, collect. And what are the different functionalities in the PySpark? I'll be discussing in brief about each and everything with the many working examples, right? So these are the things, right? We have got a lot of data frame API functionalities, and also like PySpark SQL functions, aggregate functions, window functions, date and timestamp JSON, read and writing JSON, PySpark built-in functions. So all these are the built-in functions, split, sub, overlay time. So many functions given by PySpark, right? So using that, you can perform these operations. So all this with many working examples. And handling multiple file formats. We'll be working with CSV files, JSON files, Parquet files, Excel files, XML, Avro, and WARC files, and also like historical data load, incremental data load, data transformations, aggregations, join operations, right? Union operations, external sources working with integrations with MySQL, right? And transformations, narrow and wide transformations, adding new columns, dropping columns, renaming, adding of new rows, dropping rows, handling nulls, joins, writing back to external sources, creating tables, Databricks streaming API. What is streaming process of this? Streaming using PySpark, handling bad records, streaming data with Gen2 Lake, load with the data with Databricks Lakehouse. Difference between data lake and delta lake, introduction to delta lake, features of delta lake, how to create delta table, match statements, SCD type 1, type 2, right? Handling data deduplications, right? Yes, workflows in Databricks. So, introduction to this workflows, creating and managing Databricks jobs, scheduling and Databricks jobs, and monitoring the Databricks jobs. This the 20 topics in brief I'll be discussing, right? So about this, both PySpark and this Azure Databricks. Yes. Yeah. So yes, some query was asked. Now you can just check with the. So one thing, PySpark course with Azure database and some different score. Abhishek, right? Yes. So PySpark, how to execute an on-premise, that is one, and PySpark within the cloud environment. Yes. Abhishek, right? You just were asking about a query, right? How in the on-premises, how we can create our own cluster, not in the cloud cluster like that. How we can execute on the yarn cluster, Hadoop yarn cluster, right? And how we are going to design that cluster uh, physically, right? Yes, we are going to maintain the cluster. But in the cloud, the cluster is invisible. Just you say 10 systems means 10 systems you will be getting, you will be charged for that. Here, what is happening at the background? But here in the on-premise side, you are going to design everything. You are going to work on this. That is on-premise one and the cloud one. So in this course, we'll be discussing the cloud, Azure cloud, right? Databricks.
Uh, yeah. Am I audible, sir?
Yes, yes, yes.
Yeah. So my name is Abhishek. So my question was, I saw some difference in the course content for only PySpark and PySpark with Azure Databricks. Like there, you have mentioned the Spark context or optimization of the Spark code and all those things, PySpark code and all those things. But here in this course, I didn't see that structure, like creating a Spark context and all those things with the starting and then optimization of the PySpark code,
Uh, so
like
yes,
that.
yes, yes. So here, majorly, right, in PySpark, right, data frames are mostly used today. PySpark in data frames are the mostly used data objects, right? So here I'll be briefing mostly on these things. All this, everything, if you see the main functionalities about this PySpark, these things. All this PySpark data frame functionalities, PySpark SQL functionalities, built-in functionalities. See, thing is, takes lot of time, right? It's a time-taking process, Databricks and these things. Mainly, if we talk about, if you go for any other training site, right? I don't know, like they'll just give overview of this PySpark and this Azure Databricks. But here I'm giving the in-depth knowledge about the PySpark, in-depth knowledge about the PySpark because it's a main execution weapon, right? In the data engineering side. So just I'm going to discuss the entire thing within the PySpark, and also you are going to get the entire knowledge on this Databricks, Azure Databricks, right? So
Okay, yeah.
the main,
So
the
in
main,
this
the
course, we are
main, the main core functionalities, everything is covered in this PySpark. See, all this is regarding PySpark. This everything is PySpark.
okay.
But there are some things which are outdated that I'm not discussing now, as you said, that context. But in the previous old versions of this Spark, they are there. But now that outdated things I'm not discussing.
Okay, okay, yeah, sure.
Sir, it is weekdays
So
batch no,
everything.
for 8 to 9.
1 second, I'm coming to it. So one thing, right? Everything from ground level to you will be making you to understand everything, right? Whatever I discuss about this, right? Only thing is regularity to the session and interacting with the session, responding in the session. Whether your answer is correct or wrong, try to keep responding so that I can understand the level of your understanding that your answers. So whether to go with another example or another flow, right? Yes. The only thing is yes, but here in brief about these things. So it takes around 2 months for this entire course. Databricks and PySpark. And I'll be taking some extra sessions also whenever required. I'll pre-intimate, right? So every day the session timing is 8 to 9, right? From Monday to Friday. But sometimes on Saturdays I'll pre-intimate if I'm free on Saturdays. If I'm busy with the weekend classes on the Saturday and Sunday, even I'm handling the PySpark weekend classes. You're comparing the syllabus of PySpark weekend batch, right? Here with this. So weekend batches I'm handling, but whenever I'm free, I'll be taking some classes or days where we'll be working with more work examples on this. You'll be getting the clear soft copy of the notes. Each and every soft copy of the notes you will be getting. Each and every session video also you are going to get it. But 8 to 9, when the class completes at 9 o'clock, by 12 o'clock, you will be getting the video to your Google Drive. Every day one video. Even if you miss any session, you can go to the video and attend the next session, right? For a better understanding, right? So yes, and
What
a, a WhatsApp group, separate WhatsApp group for this, where you can easily interact. And if you get any error, you can take the snap of it and post it in the WhatsApp group. Yes, clear video, clear notes, a WhatsApp group, and assignments and tasks to work with. And the sessions, right? I recommend you people do parallelly along with me, whatever the practicals, right? You can do parallel because there are some configurations where you will be doing. If you feel means immediately, if you get any error, immediately you can share the screen, and even wherever you need to know where the errors will occur. There are a lot of things where we do a lot of configurations here. I'll be showing you those things. Okay, even you can do parallel along with me. If any error, you can share the screen, right? Yes.
what is the
Yeah.
prerequisite? Like,
See, the prerequisites are everything I'm discussing as part of this course only. There is basic SQL, basic
like
SQL knowledge if you have got and what about that Hadoop related things, some basic things that what I'll be discussing right at the start. Everything, what are the prerequisites, everything I'll be discussing. All right. There is no prerequisites, right? Everything I'll be discussing as part of this course. You will get the full
no
knowledge.
any coding knowledge, like any basic language.
Language means yes, as I forgot to say, yes. Python basics you need to know. Python
Okay.
Python basics you need to know. You need why because here it is code based because
So are we
Spark
also
is
covering Python in this course?
1 second. I'm coming to it. Spark implementing using Python. Spark implementing using Python, right? Yes.
So
So
Spark and Python be same
yes,
syntaxes, or
yes. Spark.
Spark and Python both has same syntaxes like print, loops, operations, everything.
See one thing. Spark is not a language. Spark is an processing engine execution model. Python is a language. So for implementing Spark, you can choose any language, either Python, Scala, or Java. So we are choosing Python, which is mostly used in the industry. So how we are going to write the code and how do we are using the Spark functionalities within this Python codings, right? But Python coding is not that much, just basic Python knowledge, not all that object-oriented programming, all this. We are not building any web applications here, only the
Mm.
basic Python. I'll be just briefing you about this Python. I'll be just brief you about the Python syntaxes, right? Before I go with the practical for the basic Python syntaxes, right? To make you understand about those things. Before I go with the practical, the Python syntaxes once I'll be discussing.
And in
Okay.
SQL only CRUD is enough.
In SQL also basic how to create a table, insert normal basic operations, create table. That too, if you doesn't have knowledge also during the course, you'll understand how we are creating, inserting this.
Mm.
If you have got, it is better, right? So,
But why to
yes,
learn this? I don't did not get anything. Why we
why
have
to?
to learn? Why we have to learn Spark? I did not get. Where we are you? I mean,
See, I was discussing about the same thing for huge data in petabytes of data, right? If you want to process, just I was saying this, why you want to means, if you take the speed time taken by this days of time, it has taken hours of time, but Spark, this Hadoop has taken minutes of time. Compared to this, it has got very high speed, right? Hadoop has got very high speed where it has processed in minutes of time. Compared to that, Spark is 100 times faster, I'm saying. See the speed of Spark then.
I
Today
mean,
industry speed, processing speed, huge data, 100 TBs of data processing, right? It's a very high rate of speed Spark is going to process. So today, everywhere, if you see every applications are generating huge data. Today, industry also is expecting a tool which can process huge data at quick time. So that's why today Spark has got high demand in the market. It is one of the in-demand tool in the market, right? Even if you see the salary packages for this PySpark and this Azure DataBricks with PySpark, right? So it has got a huge salary package. You can just check ADB, Azure DataBricks and PySpark with combination with PySpark. You need to have knowledge on this PySpark because total execution happens using Spark. If you are becoming a data engineer, means Spark is the main thing required, right?
So
So
for
if you want to just change your stream, right? If you want as a career wise, if you want to have a better thing, this is one of the better choice I was saying.
uh, uh, like if for building website we are using Python, then React.js, like that
See,
for
one thing, we are not developing any web applications here using this. We want to do
but
any kind of
to develop by using
online
PySpark.
online processing. Online processing we are not going to do. It's not for web applications creations. It is
Okay,
for
but
it
what
is
going to do like if, for example, Amazon a company is there where we are going to use this Spark.
so for example,
Mm,
you have got 20 branches in 20 cities.
mm,
You want to analyze, see, you want to analyze the data, which product means the sales are good, which product the sales are bad. Means you are going to extract the data from all the 20 branches. You are going to bring to at one place where huge data will be there, where you are going to have huge data. After that huge data, you are taking to one place, and that from that huge data, as per your requirement, you are going to apply the business logic and you are going to process it. Which product you are going to filter the data and you are going to process the data and just you are going to analyze and you want to process the data. For these things, not for making some kind of request response. It is not for request response architecture. It's not like client server architecture. We are not following in this. Clearly understand this Spark is not for client request response architecture or not for client server kind of things. It is master slave, single master, multiple slaves. In the tomorrow session, I'll be briefing you about that master slave architecture, but not for any web applications or website buildings for this, not for those kind of things. Means if we talk about that online applications, we say it's not for online applications, it is for batch applications. Batch applications means millions and trillions of records you are pulling and you are processing there. Means not like online. Online means one transaction happening. For one transactions, two transactions, for that MBs of KBs of data, you no need of Spark. For MBs of just for one transactions, two transactions, right? So for huge data, for huge transactions, right? Generally for processing those, we go for Spark.
okay.
Right? And for online applications means you give a request, you will get a response. That is what a typical online applications, we do develop web applications for that, not for those things. Right? Okay. So
Sir.
tomorrow also everyone can attend the session, same time at 8 o'clock, using the same link to see more discussion. Tomorrow just I'll be giving knowledge on this data, Azure Databricks and Azure Databricks, right? Yes.
Hi, sir.
Yeah. Someone was asking if, yes.
I am Ram here.
Yeah. Yeah,
Uh,
go ahead.
how much percent of will cover in theoretical real-time scenarios in this course?
What is that? How many?
How real-time scenarios? How much percentage in this course we have covered?
See one thing, Ram. First, some 3 to 4 sessions only it will be theoretical. Everything will be practical oriented. You will be getting this. So all the real-time scenarios working with many working examples I'll be discussing. And a typical 4+ years of experience, how much knowledge he is going to get, you are going to get that knowledge in this.
Yeah, actually, I have around
Because,
3 years
because
experience.
no, whatever your experience is there, I'm saying if you, even if you are a fresher, a typical 4+ years experience guy, how much knowledge is going to have, more than that you will be getting in this. Because in brief, in depth, I'm going to discuss about all these functionalities in this PySpark and Databricks.
Okay. And how much duration it will complete? Sir?
Around 2 months it takes.
Okay, actually, they said like 4 months. That's why I'm asking.
That is total Azure data engineering.
Okay. Within 2 months,
Okay.
you will complete both PySpark and ADB, right?
Yes, around 2.5 months it takes.
Okay. Okay.
Around 2.5 months it takes, right? Yes. Don't measure the knowledge or subject, right? So we'll be spending more time whenever required. I'll be taking extra sessions as well. but
Yeah.
it won't complete within 2 months. It will not less than 2 months or 2.5 months. It will take around 2.5 months because
Okay.
we are discussing in, you can see the course content, right? How brief and how brief, and you can also compare it with other training sites. Fine. You will be getting all the knowledge on it.
Yes, sir.
Yeah,
All the sessions will be interactive sessions only. At any point, you can unmute and you can ask the queries. Yeah. And at the end of the course, right, you will be getting great comment on this PySpark and this data. Yeah, someone asking query, right?
Yeah,
Yeah,
hi.
can you share the notes today?
Pardon?
Can you share the notes which we
Yes,
discussed today?
I'll be forwarding the notes. 1 second. Okay. 1 second. Now I'll be forwarding. Just I'll keep this in that. Today we have did very less. Tomorrow I can forward it both this and tomorrow session. We have did very less, right? Tomorrow. And
yeah,
it's
Monday
clear,
weekly only 5 classes or 7 classes.
Monday to Friday our sessions will be, but sometimes on Saturdays I'll be taking. See if you can see this. Don't worry about the notes. Clear notes, right? About this. PySpark introduction. See, this is the notes. For every batch, I'll be maintaining separate notes. This is the entire notes for this PySpark and Azure database. Topic wise, I'll be providing the notes clearly. Everyone by just checking the notes, you can understand much better. This is the entire notes. Around 70 documents you'll be getting for this. Yes. Practicals also, I said, where you can also do parallel along with me, where you will get
Is there any
command.
prerequisite? Is there any prerequisites to learn this course, or from zero with no?
Just basic Python, basic SQL.
Okay, okay.
Only that. And that's why I said I'll be discussing the basic Python syntaxes before I go with the actual practical part.
No need of Azure Data Factory like that. Anything?
No. Data Factory is different. Databricks is different. Data Factory is not code based. This is code based.
Okay, okay.
But ADF, what ADF cannot do, that is what a Databricks can do that. In the industry, what ADF cannot do, that ADB can do. Azure Databricks can perform it. There are many things, right? We can have total control about the cluster here. We can have our own, by writing our own code, so we can perform this, right? So there is no prerequisites like you need to have the knowledge about like other things, right? Everything you can understand. Okay.
Thank you.
So yes.
Yeah, but yeah, this is Nagesh. But just I need to know, like, will you provide any test account to perform this, doing these activities like lab activities, and how you need to get it?
See one thing, Nagesh, right? See,
Nagesh.
generally, this PySpark is not a basic tool, right? It's a very high-end tool.
Hmm.
PySpark is a very high-end tool. It's a very high-end technology, right? So generally, okay, for working with kind of data, just now someone said data factory, Azure data factory. For that, okay, you
Hmm.
can get a free account, you can work with that. But to get the full-fledged PySpark features, once again, I'm
Hmm.
saying to get the full-fledged PySpark features along with that kind of SQL kind of querying and
Hmm.
performing these things, right?
Hmm.
Uh, it is providing 2 weeks of free account. You can get a 2 weeks of free account you can get, but that
Hmm.
is not, you are not going to get the full-fledged features for it. So what I
Hmm.
can do is uh, you can go with pay as you go only,
Mhm.
means pay as you go,
Okay.
but how to get a minimum with minimum price, how you can work on it, I'll be saying. Because people without knowing, they'll keep on working, and but huge bill will be generated, right? So for
Yes,
that,
correct.
what you can do, what you should
Hmm.
do, and which one you need to delete after practicing every time after your practice is completed, which one you need to delete. So with very less price, how you can work these practicals, I'll be discussing, right? So
For
every
suppose how much the charge will be there for do practicing this all this lab
the total
activities.
total total month, approximately I'm saying a total month, because this Azure Databricks PySpark is a high-end model where you cannot see all. Free trial is free account will be there. You can create a free account, but in the free account, you won't get all the features of this
Hmm.
PySpark and this kind of SQL kind of querying.
ADF.
So what I recommend, ADF, it's not, it's small tool, right? It's so you can get everything free and you can work everything free in that. But in
But
Databricks,
we
it's
have
not.
to use that ADF also, right? We have to use in the DataBricks, right? I mean, if it is, if you want to like
You will be getting it
extract
whenever
to
you
load.
see one thing. I'll show you how to create all those things with minimum charge. I said per total month, if you're working on it, you are not going to get around 400 or 500 per month.
Okay, okay, sure. Yeah,
But
that would be fine.
for that, what you need to do is every time you need to, after practicing, hardly it takes 1 minute or 2 minutes, and maximum 2 to 3 minutes it takes to recreate it. Your data, whatever
Okay,
is there, will be there as usual, but only thing is the cluster you need to delete it every time. Otherwise, at the
okay.
background, lot of the resources will be running, which will be charged for that. So
Hmm.
people, right, we're working with this. So you will be getting all that real time how we perform in the same way. I'm going to show you the things. That's why we are going to execute on this Azure cloud with Azure Databricks, right? How we
Hmm.
are going to execute, right? So I'll be showing, but don't worry about those things with what you should do for getting the less price so that huge bill should not be generated. But if you forget once, 1 day or 2 day, if you forget, a bill will be generated, right? Yes.
Yes, yes, yeah,
So
understood.
those everything I'll take care about it. I'll just brief you about those things, right? Yes, not a worry.
Yeah, thank you.
So if you see in the market currently, right, I was talking even this Databricks PySpark developer is got the salary packages as close to data scientists. You can demand for the salaries for this if you've got a good command on this PySpark, right?
Mhm.
Means even 100% hike you can get. Means if you have got double that salary also, you can demand for that if you have got a good command on this PySpark. This is a kind of technology
PySpark
which
and
demands,
Databricks.
yes, which demands for it. You can demand for it because even industry is expecting the people who have got command in this, right? Yeah, but only
Yeah,
thing is
just
people feel that it will be very complex or that to understand. But if you're regular to the session, if you are doing the practicals, it looks very simple to understand. Only thing is the flow is important. You need to about the functionalities. What there are many functionalities features are there to perform the task. You need to have the idea about it. Otherwise, you will be writing your own code.
okay. Yeah, fine.
How
Thank you,
how
thank you.
is Nagesh, how we do perform in
Uh,
other activity? Yes,
yeah.
yes. One more thing. Yes, one. Yes. One more thing, yes, people, you can also work with Databricks Community Edition. Yes, that is, I can recommend that also, right? So Community Edition is there. Databricks Community Edition is there. It will be totally free. Means you can totally work your code on that. Databricks Community Edition is there, which is totally free. That also I will be briefing you, right? Yes. You can totally work on the total PySpark code with this Databricks Community Edition is there. With that also you can work with that code. Okay, but if you want to interact with this storages, right, with different types of storages, we need to go with it. But the PySpark code. So everything I'll be briefing you how to run in different environments, right? Yes, fine. If any small doubt, any query also, you can ask during the sessions, right?
Sir, just one more question.
Mm.
Are we also covering the persistence options like grouping and aggregations and RDD computations?
Yes,
Like,
I'll be discussing. Yes.
okay, sure. Thanks.
Mhm. Okay, so tomorrow, you people can attend same time at 8 o'clock using the same link to see more discussion on this. Fine. Okay. So people who already got enrolled for this Azure Data Engineer, you can directly attend this. But people who didn't get enrolled, you can try to enroll for getting the videos, notes, and this, right? Anyhow, tomorrow everyone can attend using the same link. Fine.
Vijay, I have one question. So
Yes.
can I attend this session? Previously, I've enrolled in Azure Data Engineering course.
Yes, people who have enrolled for the total package of data engineering, right? You can attend it
Mhm.
direct.
Okay, sure. And how about the like videos and everything? Will
What
it
is it?
be in the same folder or the previously
I will,
PDF options?
I'll just message you.
Okay, sure. Thank you.
Yeah, Vijay, most of the companies asking when I saw the profiles in Naukari, they are selling Azure Data Factory is also required. That's why it's also required for a combination of Azure Databricks.
So Databricks can do, okay, if you have got time to update with this data factory also, you can just update with the ADF also, but it is no coding involved in that ADF. I'm taking the batches on this Azure Data Engineering Total, where area it is Data Factory, Databricks, and Azure Snaps. Everything is going on. You can check with that. But here Azure Databricks is the main core part of this. With PySpark is the main core in all those data engineering. Either if you go for ADF or Databricks or Synapse, total execution happens using Spark only. But if you have got time to update with that also, you can update with that.
Yeah, similarly, you are taking that sessions also.
Yes, that session is also empty.
Okay, it's starting today
that-
onwards only. Data factory.
No, this is Databricks is starting today. But if you want that Azure Data Factory, you can be in touch whenever it starts. It will be set.
Okay. Thank you.
Already some students are already they're doing, and they did with this Azure Data Factory. In this. Okay. Fine.
I hope it's
Any oth-
it's a totally real-time experience only we will receive. That means how to actually we are from other fields. Backend actually I'm doing as a backend developer. So when I learn this course, I can able to manage when I ship the company.
Yes. Because totally because we are directly using the tool directly, the real time also they'll be using the same thing. It will be working with the same thing, right? We'll be discussing about all the things. Even that's the reason, right? You can see the course content in brief, in depth. It's not like just the 1.5 month course. Will be going 2.5 months, right?
Okay, projects also will be there. That means dummy projects.
One flow I'll be discussing at the end.
Okay.
One flow. Okay.
Yeah, thank you.
So yes, if any queries, you can ask in the tomorrow session also. So if I'm done with the queries, if there are no other queries, I'm signing off for now. Meet you tomorrow, same time at 8 o'clock. Thank you all for your time. Thank you.
Thank you.